Example 1, solving a linear inequality graphically when it has a continuous solution set in two variables. So our task is to graph the solution set for this linear inequality. Negative 2x plus 5y is greater than or equal to 10. What we're going to do to start is we're going to find the boundary. And the boundary is essentially just the line. Our job is going to be to determine which side of the line the solution set is going to be found on. We're going to do that a little later. To find the boundary, what we do is we continue with the same linear inequality, except we turn it into a linear equation. We drop that inequality symbol of greater than or equal to. We simply put it's equal to 10, and now it's a linear equation. This linear equation is going to represent the boundary or the line that we're going to graph. Recall from last semester that in order to graph these, one of the things that we can do is find the x and the y-intercepts. To find the x-intercept, we go into the equation, we substitute y equals 0 and solve for x. The y-intercept is found much the same way. To find the y-intercept, we go back into the equation and substitute x equals 0 to solve for y. So let's go ahead and do that now. So we'll start with the x-intercept. Negative 2x plus 5y equals 10 is our equation of the boundary. We're going to substitute y equals 0 to find the x-intercept. Negative 2x plus 5 times 0 equals 10. Of course, 5 times 0 is equal to 0, so that simply leaves us with negative 2x equals 10. We will isolate x by dividing by negative 2 to get our x-intercept of negative 5. We will do the same thing over here for the y-intercept. Start with our linear equation of negative 2x plus 5y equals 10. We are going to substitute now that x is equal to 0. So we will put negative 2 times 0 plus 5y equals 10. Negative 2 times 0, of course, is just 0. So that leaves us with 5y equals 10. We will divide by 5 on each side to isolate y, giving us our y-intercept of 2. We're going to take those two pieces of information over to our graph and plot those 2 points. Our x-intercept of negative 5, our y-intercept of positive 2. We are going to connect those with a line, and we'll use the line tool to make a nice straight line. Connect those 2 points. And now we have our boundary point for our linear inequality. Our next task is going to be to determine which side of the line is going to be the solution set. Which side of the line are we going to shade to indicate that that is the solution region? The easiest way to do that is to go back into our linear inequality and substitute a point that is found on one side or the other of the line. Now the easiest point to substitute, it may not always be possible, but in this case it is, the easiest point to substitute is the origin because both the x and the y values are equal to 0. So I'm going to give myself some room up here. I'm going to rewrite our linear inequality, which was negative 2x plus 5y is greater than or equal to 10. To determine which side of the solution set, as I mentioned, I'm going to substitute the origin 0, 0 to determine if I get a true statement. So negative 2 times 0 plus 5 times 0 should be greater than or equal to 10. Negative 2 times 0 is 0. 5 times 0 is 0. Should be greater than or equal to 10. 0 is greater than or equal to 10 is what we end up with. Is that a true statement? Definitely not. So since that is not a true statement, we know that the origin 0, 0 is not in our solution region. We know that the other side of the boundary is where the solution set is found. So that is where we are going to shade. As we progress through this unit, we'll figure out what color our lines are going to be and what color our shading is going to be. For now, I can shade everything green. Now, you guys were all asked to get graphing calculators. So we can do this on our graphing calculator, and that's what we're going to do now. So the way we're going to do that is we're going to start again with our linear inequality, and we are going to graph it using our graphing calculator. Now on our graphing calculator, we can't graph lines in this form, what we need to do is we need to isolate y and plug it into the y equals function. So the first thing we're going to do to isolate y is add 2x to each side of the equation, or inequality, pardon me. We have 5y is greater than or equal to 2x plus 10. And then we would isolate y by dividing by 5. And we get the inequality y is greater than or equal to 2/5 x plus 2. That's our inequality. So what we're going to do next is plug that into our graphing calculators. So I'm going to pull my graphing calculator front and center here. And turn that on. Now we're going to go into our y equals function. And I want you to put in this function 2/5 x plus 2. So we will go 2 divided by 5 x plus 2. Now this is going to graph the linear equation, which is just going to give us the boundary point. But what we want to do instead is graph it as a linear inequality. That's going to allow us to see which side of the line is shaded on. So what you're going to do is move your cursor over here to the equal sign. Pardon me, not to the equal sign, but to the slash. Sorry. And hit enter, and it'll become darker. Hit enter one more time, and what we'll get is a triangle on the upper side. Now the triangle on the upper side indicates greater than or equal to. If I were to press enter another time, what I'm going to find is a triangle goes down to the lower side. That gives me the less than or equal to. Of course, this is a greater than or equal to function, so we'll keep going back and get that triangle shaded upwards again. There we go. Now that it's there, we should be able to just press the graph button. And there's our lines. And we can see our boundary point with the shading on the appropriate side of the line, just like we had done previous. Now I'm going to hide the graphing calculator. Don't need that right now. We're going to move on to where it says your turn. It says compare the graphs of the following relations. What do you notice? I'm going to allow our person with the lovely voice to take it away from here.
I used my graphing calculator to graph each relation. Negative 2x plus 5y is greater than or equal to 10 describes the region that includes all the points on the line negative 2x plus 5y equals 10, as well as all points above this line. The graph of negative 2x plus 5y equals 10 includes only the points that lie on this line. Negative 2x plus 5y is less than 10 describes the region that includes all the points below the line negative 2x plus 5y equals 10, but not the points on this line. All three relations share the same boundary line, but they describe different regions related to this line.
And that's it for example 1.